For question 5, we've got that A is a vector here with I and j components, and B is another vector here with I and j components, and we're saying that the resultant of the two vectors A and B, so the resultant, of the two vectors A and B are parallel to C. So this means the sum of A and B must be equal to C multiplied by any number. Okay? So we're going to first of all look at our I components and then look at our j components to set up some simultaneous equations. So looking at the I components, so the I component for A is 2p, and so the resultant I components would be 2p plus the I component for B, and we're saying that is m multiplied by the I component for C, so 4m. Okay? For the j components, we've got minus 5 minus 3p is equal to minus 5m. Okay, so that's our first and our second simultaneous equation where we want to eliminate m because we don't know what m is and we're trying to find the value of p. So I'm going to multiply equation 1 by 5 and then multiply equation 2 by negative 4 so that we get both equations equal to 20m. So 5 times 1, we get 10p plus 30 is equal to 20m. Negative 4 times 2, we get 20 plus 12p is equal to 20m. And I've now got the simultaneous equations 3 and 4. I'm going to subtract my simultaneous equations so that we get them equal to 0. So I'm going to do 4 subtract 3, and I get 20 plus 12p subtract 10p plus 30 is equal to 20m subtract 20m. So 20 plus 12p subtract 10p subtract 30 is equal to 0, or minus 10 plus 2p is equal to 0, 2p is equal to 10, and p is equal to 5. For part B, we're now asked to find the resultant force of A and B, so all we need to do is add A and B together and substitute in our value of P. So A plus B, we have got 2pi minus 5j plus 6i minus 3pj. We're going to substitute in our value of P, which we found in part A, and we get 10i subtract 5j plus 6i subtract 15j, and we're going to add our I components and add our j components. So 10 add 6, that is 16i, minus 5 minus 15, we've got minus 20j. Okay, for question 6, we've got a model here of the population P of bacteria, given by the formula P equals 100 e to the power of 0.4 t. So t is the time in hours after the experiment began. Part A is asking us to use the model to estimate the population of bacteria 7 hours after the experiment began. So all you need to do here is substitute in t equals 7. So P equals 100 e to the power of 0.4 times by 7. If you type that into your calculator, you should get 1644. Okay, Part B says interpret the meaning of the constant 100 in the model. So 100, that will be the initial bacteria population, because when t equals 0, now you wouldn't have to write this down in your exam, but just to explain, when t equals 0, so time is 0, so the hours after the experiment began is 0, so when it the initial bacteria, as soon as the experiment has begun, the population is 100 times by e to the power of 0.4 times by 0, or e to the power of 0, which is 100. So 100 is the initial bacteria population. For part C, it says how many whole hours after the experiment began does the population of bacteria first exceed 1 million according to the model. So we need to find the value of t when the model 100e 0.4t exceeds 1 million. Okay? So we could start by dividing our inequality by 100, and we get e to the power of 0.4t is greater than 10,000. And then if we take natural logarithms of both sides, we get, so the natural logarithm is the inverse of e, so we get 0.4t is greater than ln 10,000, and then divide both sides by 0.4, we get t is greater than ln 10,000 over 0.4. Now if you put this into your calculator, you'll get an answer of 24 point something. So t must be 23 point something. So t must be greater than that. So t must be 24 hours. So the amount of hours until we exceed 1 million is 24 hours.